Indexes and query optimization. This might be the single most important database concept you will ever learn. Databases are robust with one thing: reducing disk rates. Everything like indexes, execution plans, joins, partitioning, optimization ultimately tries to reduce how much data the database must read from a disk. The real problem: imagine a users table with 100 million rows. Now you search for one user without an index. The database may scan every single row one by one. This is called a full table scan or a sequential scan. Very expensive. Think about searching a word inside a huge book without an index. You read page by page, but with the book index, you jump directly to the correct location. Database indexes work exactly the same way. What is an index? An index is a special data structure that helps the database locate rows faster. Instead of scanning everything, the database can jump directly to the required rows. That's why indexes dramatically improve query performance. Now, here is the important trade-off. Indexes improve reads, filtering, joins, and sorting. But indexes also increase storage usage and write cost. Why? Because every insert or update must also update the index structure. Binary tree index. The most common index type is binary tree index. Think of it like a balanced searchable tree. Instead of scanning every row, the database traverses the tree efficiently. That reduces search complexity from O of n to approximately O of log n. Why binary tree is default in databases? Binary tree indexes are powerful because they support exact lookups, range queries, and sorting. That's why databases use them by default. One index solves multiple problems efficiently. Hash index. Hash indexes work differently. They use hashing to directly locate values. Very fast for exact equality lookups, but terrible for sorting, range scans, and between queries because hashes destroy ordering. Composite indexes contain multiple columns, and this introduces one of the most important optimization rule called the leftmost prefix rule. Think of it like a phone book sorted by last name first, then first name. Leftmost prefix rule. Suppose your index is user ID and status. Efficient queries include user ID alone or user ID plus status. But searching only by status is less efficient because index ordering starts from user ID first. Explain. Let's talk about how databases think. Explain shows the execution plan, meaning how the database plan to execute your query. This helps engineers understand whether indexes are used, which scans happen, and how expensive the query may become. Important distinction. Explain only shows the estimated execution plan, but explain analyze actually runs the query and shows the real timings, actual rows, and true execution statistics. Covering index. Now this is an advanced optimization concept. Suppose your query needs user ID and name. If both exist inside the index, the database may answer the query directly from the index itself without touching the main. Here are common beginner mistakes. Select star rates unnecessary columns, which increases input-output operations, and applying functions on indexed columns like lower of email may prevent index usage entirely.